Welcome to our channel, where we explore the engineering and technological wonders that protect our world from the forces of nature. In this episode, we will discuss seawalls, amazing structures that protect us from the threat of flooding and storm surges. Prepare to be amazed by human innovation, defying the forces of nature. Don't forget to subscribe to our channel, activate the notification bell, and give a like if you like this content. Comment below if there's a particular seawall you'd like to know more about. Enjoy watching, and let's start our adventure.
The Thames Barrier stands majestically over the River Thames, like a strong fortress, protecting the heart of London from the threat of flooding coming from the North Sea. Built between 1974 and 1982, this barrier is a silent witness to humans' efforts to conquer nature for their safety and welfare. The location is strategic, connecting Silvertown in the London Borough of Newham and Charlton in the Royal Borough of Greenwich. These gates, each 61 meters long and weighing 3,300 tons, are made of hollow steel so they can float, making it easy for them to be raised and lowered as needed. Whenever the threat of high tide arrives, the Thames Barrier is ready for action. In around 75 to 90 minutes, 10 of these sturdy steel gates can be lifted, forming a barrier protecting London from storm surges and high tides. This system is fully automated. As one of the world's largest moving flood barriers, the Thames Barrier not only symbolizes technological sophistication and an engineering marvel, but also London's commitment to protecting its people and its future. Amid the challenges of climate change, this barrier stands tall, ready to face the next tidal wave, always ready to protect London from threats lurking from the sea. MOSE, Modulo Sperimentale Elettromeccanico, stands as the last line of defense against the threat of flooding that often threatens a city famous for its historical heritage. MOSE is a modern engineering marvel designed to protect Venice from the increasingly frequent acqua alta or high tide phenomenon.
MOSE consists of a series of large hinged gates placed at the three main entrances to the Venetian lagoon: Lido, Malamocco, and Chioggia. These gates usually lie on the seabed, but when seawater rises above a certain level, they can be filled with air to float and form a barrier that prevents tidewater from entering the lagoon. When high tide is predicted, the MOSE system is activated. The air-filling process causes these gates to rise in about 30 minutes, creating an invisible but very strong wall at the mouth of the lagoon. Once the threat of high tide passes, these gates sink back to the seabed, allowing marine traffic and ecosystems to return to normal functioning. MOSE not only serves as a protector of Venice from the threat of flooding, but also as a symbol of technological progress and human dedication to the preservation of cultural heritage. Every time the MOSE gate goes up, it is a testament to the power of human innovation in the face of nature's challenges. Samangeum is a coastal land reclamation project located in North Jeolla Province, South Korea. This project started in 1991 and was completed in 2010. The main objective of this project is to convert unproductive tidal areas into lands that can be used for economic activities such as agriculture, fishing, and industry. The Samangeum project creates a dike about 33 kilometers high, separating the reclaimed area from the Yellow Sea. The reclaimed area covers approximately 40,100 hectares, making it the largest reclamation project in South Korea. The impact of this project on the environment and local communities is quite significant. Some support the project because of its huge economic potential, while others are concerned about its negative impact on the coastal environment and the traditional livelihoods of local communities who depend on the ecosystem. The Samangeum project has been controversial due to various considerations, including environmental, economic, and social impacts. However, it has also become a focal point in regional development efforts in South Korea, reflecting the complex challenges between economic development and environmental sustainability. Great Wall of Japan. One of the largest projects is the construction of a series of sea dikes, often referred to as the Great Wall of Japan, which stretches for several kilometers along Japan's northeastern coast. This seawall is part of Japan's efforts to mitigate disasters, especially after experience with various large tsunamis in history, including the most famous, the Tohoku tsunami in 2011. The bitter experience of the Tohoku tsunami on March 11, 2011, which caused massive destruction and significant loss of life, became a major impetus for the upgrading and construction of seawalls in Japan. After this disaster, the Japanese government allocated large resources to build higher and stronger embankments and improve early warning systems. While these walls provide a sense of security and have been effective in some areas, there are concerns about their long-term sustainability and ability to adapt to climate change. Japan continues to evaluate and improve its tsunami defenses, integrating new technology and scientific research to increase resilience. DeltaWorks is a large engineering project carried out by DeltaWorks, or in Dutch known as Deltawerken, which is one of the largest and most ambitious water management projects in the world. This project was built by the Netherlands, a country where most of its territory is below sea level and is very vulnerable to flooding. In 1953, the Netherlands experienced a devastating natural disaster, namely the North Sea flood, which caused more than 1,800 people to die, thousands of livestock died, and many areas were submerged in water. This disaster prompted the Dutch government to design and implement a project aimed at protecting the country from the threat of future flooding. DeltaWorks consists of a series of dams, sluices, and barriers, such as Oosterscheldekering, Messelenkering, Haringvliet Dam. The Eider Barrage is a clear example of the ability of human engineering to protect a region from the devastating forces of nature. Combining modern technology and thoughtful design, these structures not only protect against flooding, but also support the sustainability of the local ecosystem and surrounding economic activities. As the challenge of climate change continues to grow, the Eider Barrage remains an important component of Germany's coastal protection strategy. There are 5 large sluice gates that can be opened and closed to regulate the flow of water between the Eider River and the North Sea. These doors function to control water levels and prevent flooding during sea storms. Eider Barrage protects the surrounding area from sea flooding and storm surges. With this barrier, the area around Tunning and other lowlands is protected from the threat of seawater entering land, and can effectively control the flow of water between rivers and the sea, maintaining ecosystem balance and preventing coastal erosion. This barrier-integrated bridge provides an important transport link, connecting the regions around the mouth of the Eider River. Thank you for watching our video about the world's most impressive coastal protection forts. If you found this information interesting, don't forget to give it a like, leave a comment, and subscribe to our channel for more interesting content about amazing engineering structures around the world. Also activate the notification bell so you don't miss our latest updates. Thanks for watching, and see you in the next video.